Hi, it's Mr. Moser, and welcome to my podcast on states of matter. Okay, so gas has some laws that we need to talk about, and the first one we're going to talk about is Boyle's law. So in the mid-1600s, the British scientist Robert Boyle recognized that the pressure and volume of gases were inversely related. So they're inversely related. Inversely related, which means that as one of them goes up, the other one goes down. So we have pressure and volume. So as the pressure goes up, the volume goes down, and that's inversely related. So Boyle's law states that for a fixed amount of gas at a constant temperature, the volume of gas increases as the pressure decreases. So conversely, the volume of gas decreases as the pressure increases. And so you can see here, as we're increasing the volume of this container, we're pulling this up and increasing the volume of the container, the pressure inside of here is going down. Here, we're pushing down, we're decreasing the amount of volume inside of this container, same container. And as we decrease the volume, then the pressure inside goes up. And here's a graph here that just shows you how that works here. Here's volume and pressure. So as the pressure goes up, volume's down, pressure's up. When the pressure goes up, then the volume's down. And this is just like being able, so that we can compress air, compress the gas. Compressed gas is what makes it possible for people to get married underwater and to be able to go scuba diving and be able to breathe that air. They breathe it out of a container that has the compressed gas inside of it. Okay, the next law that we're going to learn about is Charles' law. So how do you pop a balloon? The easiest way to pop a balloon here, this was a balloon right here. The easiest way to pop that balloon is to stick a pin in it, like this lady has done, and pop that balloon. But another way that we could pop the balloon, maybe if we wanted to pop these balloons that's holding this guy up, another way that we could do that is to increase the heat. So Charles' law says that for a fixed amount of gas, the volume of gas increases as its temperature increases. So here's our volume of gas, and as we increase the temperature, the volume of the gas increases. So if we take some heat and put it underneath these balloons here, so we have a fire here that we put underneath there, it's going to heat up those balloons, and as those balloons heat up, the volume inside of those balloons of air is going to continue to increase until eventually it overcomes the rubber and it pops those balloons. So here we have the volume right here of the gas. We put some heat to it. As we put the heat to it, the volume increases inside of there. And that's Charles' law. Okay, so now we want to talk about the changes of matter. So all changes of state involve a change in energy. So you see these glaciers down here. These glaciers are calving into the ocean because the glacier is melting. For a glacier to melt, it must be heated. Glaciers are water in a solid state. And when they're heated, the particles move more rapidly. Faster motion means more kinetic energy. And the increase in average kinetic energy causes the temperature in the solid to rise. When the solid has accrued enough energy, the particles vibrate so intensely that they overcome their attractiveness for each other, the attractive forces, and they slide past each other. And the solid turns into a liquid. So the change of state between a solid and a liquid is called melting. Now the opposite process, changing from a liquid to a solid, is called freezing. So when the liquid is cooled down, here we have this ice cream, and it starts out as a liquid, and when that ice cream is cooled down, it loses thermal energy, slowing the particles down, and the attractive forces overcome the motion of the particles, and it freezes them into place, and so that they just vibrate around a fixed position. Okay, vaporization is another change of matter. So on a hot day, or while doing exercise, a person perspires or sweats. So you can see this sweat coming off of this tennis player as he has been working out really hard. And this sweating is the body's way of cooling us down. So how does that work? When liquid absorbs heat, the motion of the particles increase, and the temperature increases until the liquid has enough energy to overcome its attractiveness to itself. At that point, the liquid turns into a gas, and it spreads out, and it takes the body heat with it. When a liquid changes from a gas to a liquid, we call that vaporization, right up here. So vaporization that occurs throughout a liquid, when we have this liquid right here and there's vaporization occurring throughout the whole liquid, we call that boiling. And then if we have vaporization that's happening over a large surface, and on the surface, just the surface is evaporating, we call that evaporation. So those are both types of vaporization, which is one is boiling, happening throughout the entire thing, and evaporation, where it's just happening on the surface. So eventually, this puddle, it's going to evaporate and go away. And then he or she won't have any more fun in the puddle. So anyway. So we have these fluffy clouds here, and they really look like they're soft, but actually, what they are is droplets of liquid inside of here, just little droplets of liquid all the way through there. So the drops form when water vapor in the air changes from a gas to a liquid. And this change from gas to liquid is called condensation. And the cycle between evaporation and condensation, especially out on our oceans, drive our weather patterns. We have large areas that evaporate over the ocean. All that vapor water goes up into the atmosphere, condenses into clouds, and then those clouds move over the land and cause our weather patterns. The last change of state that I want to talk about is sublimation. So a change in state in which a substance goes directly from a solid to a gas is called sublimation. During sublimation, the solid picks up enough energy so that they change from the tightly packed together, from being really tightly packed together, to being spread apart. So here we have this picture of this is dry ice. All it is a solid carbon dioxide here in a solid state. And when it heats up, it goes from this solid here directly to a gas, and you can see all this fog that's coming off of it. That's just a gaseous CO2. And carbon dioxide isn't the only thing that does this. Snow also does this. So in the springtime, you might have really big banks of snow, and then just overnight, it seems like the snow is gone. But it never melted. It never went to a liquid state. That's because it went through sublimation, where it just went directly from a solid into a gas. Okay, so let's review what we've learned. Then we have these gas laws. Boyle's law, which says that as the pressure increases, the volume decreases because they're inversely related to each other. And then Charles' law, which says that as the temperature goes up, the volume goes up. Or as the temperature goes down, the volume of the gas goes down also. And then last, we talked about the changes in state. So we have the three states. We have a solid, a liquid, and a gas. And when we go from a solid to a liquid, we call that melting. When we go back from a liquid to a solid, we call that freezing. Okay, and then when we go from a liquid to a gas, we call that vaporization. And vaporization could be boiling, and it could be evaporation. And then when we go back from a gas to a liquid, we call that condensation. And then the last one that we just talked about is when we go from a solid directly to a gas. And we go directly from a solid to a gas, that's called sublimation. Okay? Thanks for watching, and I hope that was helpful for you.